3.1. We said that x to the nth power prime is n x to n minus 1. What we remember from before is something that has to be memorized. This is 1 over 2 the square root of x. We also know that 1 over x prime equals negative 1 over x squared. This is where our discovery is from before. Lectures from before, we remember these. And we also remember that e to the x prime is e to the x, the nicest possible function. We also looked at, with the graphing calculator, we looked at the limit as h approaches 0 from e to the h minus 1 divided by h. What was this equal to? Very important. Just go back to your notes for now. This is important. Go back to your notes. Yes, please. Go back to your notes. What was the limit as h approaches 0 from e to the h minus 1 over h? It must be in your notes. How much? Careful. Well, I'm only asking about the quantity limit as h approaches 0 from e to the h minus 1 over h. There's no x. There is no e to the x. How much? Exactly. Thank you. Well done. That's how we got the e to the x, because this limit was 1. Perfect. Awesome. So this is what we know from 3.1. Let's practice a little bit more. And I would like to look at problems 35 and 36 on page 182. Please choose. Okay, I will. 35 then. On page 182, we're given a function which is y equals x to the 4th plus 2e to the x. And we are given an interval. Let's see what they are asking us to do. Find equations. This is not an interval, it's a point. Find equations of the tangent line and normal line to the curve at the given point. Okay. So I don't really know, or I don't even care how this function looks like. But this is function y, and I have this point somewhere, 0, 2. And I'm asked to determine two things. I'm asked to determine the equation of the tangent line at this point, P. So this is the tangent at P. But I'm also asked to determine the equation of the normal line at P. The normal line is the equation, is the line that is perpendicular to the tangent line, to the graph of this function, at the point of intersection of the tangent and the graph. So I'm asked to determine the equation of this line, and I'm asked to determine the equation of this line.
So you just said the normal line
is perpendicular to the tangent at the point. Yes. What do we know about two perpendicular lines? What is the relationship between their slopes?
Same. Or no, they're opposites.
A negative reciprocal of each other. Very good. So if I have this one, let's say m1, and this one will be m2, m1 equals negative 1 over m2. So this is for perpendicular lines. I never remember this like it. It's the same thing. I prefer multiply, cross multiply. And I say m1 times m2 equals negative 1. Same thing. Cross multiply with this one. It's easier for me to remember it that the product of the two slopes has to be -1. But it's the same thing with m1 equals -1 over m2. Very good. So in order to determine the equation of this line, I have a point. I'm starting with the tangent. So I have y minus y1 equals the slope times x minus x1, in which I have the point 0, 2, 0 for x1 and 2 for y1, but I do not have the slope at 0. So I have to find the slope at 0. So this is f prime at 0. But I have the function. And I can, yes, please.
What is that written underneath reciprocal?
Perpendicular. That's a sign for
Right.
perpendicular lines.
Oh.
Perpendicular lines. Sorry about that. So I have the function. I will determine f prime. Can anyone give us f prime? Four x to the third plus 2. Very good. So now I have to determine f prime of 0. How much is f prime of 0?
2.
Very good. This is 0, and e to 0 is 1. 1 times 2 is 2. So now I have y minus 2 equals 2 times x, because x minus 0 is x. So then y equals 2x plus 2 is the equation of the tangent at P. The equation of the tangent at P. Perfect. Now, can anyone give us the slope of the normal line? The slope of the normal at P. So this will be -1/2. Do you all agree? Because the product has to be -1. So 2 times -1/2 equals -1. So this must be the slope of the normal line. Agreed?
So
Yes? Go ahead, please.
you'll just put -1 and then over whatever substitute. Or
Yes, if this is 2, then -1/2, so that the product is -1.
You just flip side. So if there's nothing, they just put a 1 there.
So now I have again y minus y1 equals the slope times x minus x1, where the point must be the same. The normal line is at the same point where the tangent is at the same point, but the slope this time will be -1/2. Are you with me, everyone? Questions? So the equation of the normal line will be given by y minus 2 equals -1/2 x, and then y equals -1/2 x. Excellent. So this is normal line at P. Okay, I would like to look also at 63 and maybe 68. So let's look at 63. These are all applications of what we looked at. Find the second degree polynomial. Second degree polynomial. Such that P of 2 is 5, P prime of 2 is 3, P double prime of 2 is 2. Can anyone give us the general form of a second degree polynomial?
X squared
A, x squared.
plus BX.
Awesome. Perfect. This is it. This is the general form of a quadratic polynomial. No doubt about it. Some coefficient times x squared plus some coefficient times x plus some free term. This is it. Thank you very much. Good.
So would C be 5 in the first one?
Yes. No, P of 2 is 5.
P of 2, yeah, and then the But TF2, yeah.
So we'll get to it in 1 second. So we're going to come back here, but I would like you now to give me p prime of x, please. Because some p prime is involved in the problem. So can anyone dictate p prime? Very good. And also p double prime I need as well. That's it. We're going to create a system. How many equations do I need? Yes, why do I need 3? Because I have how many unknowns? Exactly, I don't have A, I don't have B, and I don't have C. So that's why I need 3 equations. Can anyone start with the third one? Let's give me the third equation, please. This one. 2 times A, so when x is 2, so 2A equals 2 indeed. So then you will automatically say that A is good. But let's not worry about it right now. Now, please give me the second equation. Careful. So it's p prime of 2 is 3. 2 times A times
4x.
exactly 4A. You mean 4A plus B equals? Very good. We have to replace x by 2. 2 times A times 2 is 4x plus B equals 3. Agreed? Okay, now let's write the first one. So this is done, this is done. I would like to write the first one.
4a plus
4A
2b
plus 2B
plus c
equals?
5.
That's it. So let's go with back substitution. That's the easiest thing to do. We already determined A. So let's put A in here, which is 1. How much is B? Yes, it is -1 indeed. So now I'm back to the first equation in which A is 1 and B is -1. So 4 minus 2 will be 2. So C will be?
3.
That's it. So given the information and the given conditions, we were able to construct the unique polynomial, the only one polynomial that fulfills the given conditions. Can anyone dictate? This is the only one, thank you, the only one that fulfills the given conditions.
What was it? I'm sorry.
I replaced A by 1, I replaced B by -1, and I replaced C by 3.
Oh, okay.
Any questions? Okay, so let's look at one more problem and then we continue. Let's say we have 75. F of x equals x squared if x is less than or equal to 2. And it's mx plus b, they say, if x is greater than 2. First of all, we didn't even finish reading the problem, but I'm going to ask you what type of function is it? Of course, it's defined piecewise. It's a piecewise defined function. It has 2 pieces. Perfect. So now I read on. Find the values of m and b. So these are the unknowns. M comma b unknown that make f differentiable everywhere. F of x differentiable by everywhere we mean on negative infinity to infinity. That's what we mean by everywhere. Okay. What is the first condition for a function to be differentiable? But it's not the only condition. But what exactly? Awesome. So some of you forgot, say it again.
Continuous.
Continuous. Some of you forgot this concept on the test. We can't forget about it. Okay. So I will have to write number 1 that x squared and mx plus b are continuous everywhere. Why? Since they are, thank you very much. There is never a discussion about a polynomial not being continuous. In step number 2, I will have to study continuity at, of course, I will have to write the definition that the limit as x approaches 2 from the left must equal limit as x approaches 2 from the right, and must equal
2.
close f of
X equals 2. Right.
exactly. Now, which function do I write from the left of 2? I want to write it right here. Which function do I write from the right of 2? Perfect. So now I'm looking for this answer, please.
4.
Now I'm looking for this answer, please.
2m plus b.
Awesome. And now I'm looking for this answer. Good. So what is the first equation? I'm going to call it A. Give me an equation that
R equals 2m plus b.
absolutely excellent. So now this guarantees continuity. It does not guarantee differentiability yet. Because remember, a function can be continuous, but it may have a vertical tangent, or it may have a cusp or a corner. This guarantees that it does not have a jump, but it does not guarantee that it doesn't have a cusp, a corner, or a vertical tangent. So now step 3. F prime of x. Only for x less than 2 and for x greater than 2 guaranteed. I have not said anything about equal to.
2m.
Perfect. And then the other one.
N.
Indeed. Awesome. But notice that I cannot talk about x equals 2 at this point. This will be my step 4 and the last one. Step 4. Okay. What happens, forget about the vertical tangent, which is a different situation. We are talking about polynomials here. So there is no situation of a vertical tangent. But how do I avoid having a cusp or a corner? I avoid having a cusp or a corner by making sure that at each and every point, this f of x has how many tangents?
1.
Exactly 1, right? Because if it has a corner, at this point it has this tangent on one side and this tangent on the other. If it has a cusp, it has this tangent on this side and this tangent on the other. But if it's this, at every point it has a unique tangent. How do I guarantee that at x equals 2, there is a unique tangent? Which means I avoid having a corner and I avoid having a cusp. What is the definition of the derivative? The derivative is a, thank you. So both sides have to have the same number. Because here, this is a negative value and this is a positive value. This tangent is negative and this tangent is positive. Right? So I have to make sure that the limit from 2x as x approaches 2 from the left must equal or equals limit as x approaches 2 from the right of m.
M equals 4.
Exactly. And that will guarantee just one tangent at x equals 2. Very good. So what is this?
4.
What is this?
4. Well, n.
Very good. And this is my condition B. Now I put A and B together and create a system. A was 2m plus B equals 4. And the second one was m equals 4. So therefore, from here, I have already that m equals 4 and b must equal.
Negative 8.
So that's
No, negative 4.
negative 4. So now, can anyone give us the equation? Not the equation. Can anyone give us the function that is differentiable everywhere? X squared for x less than or equal to 2. And 4x minus 4 for x greater than 2. This function is differentiable everywhere. We made it so. Very good. So there is no cusp and no corner. At every point on this function, there is only one tangent. The function is continuous, and at every point, there is only one tangent, which means the function is differentiable everywhere. It has a unique tangent at any point. Okay, so in section 3.2, we are going to look at two different rules. One is called the product rule, and the other one is the quotient rule. Both of them are for differentiation. So the product rule for differentiation and the quotient rule for differentiation. What does this mean? Well, when we have a product of two functions, how do we differentiate that? So here it is. Function f multiplied by function g, everything prime. Notice that this does not mean 5, a constant, times g. So the two functions, one of them is a polynomial, the other one is an exponential. Okay? Say it again.
The derivative times the derivative.
Nope. Very special rule. We need to memorize this. F prime multiplied by g plus f multiplied by g prime. Nothing that you would have expected. Your book reverses this order. It's up to you. I prefer keeping them in the same order, but this is my habit. And if you would like to change that, I'm fine. I like function number 1 times function number 2 prime. I always keep them 1, 2, 1, 2. 1 prime multiplied by the second one plus the first multiplied by the second prime. It's easier for me to remember. It's a habit. I grew up with this. So if you want to change it and say 1 times 2 prime is 1 prime times 2 plus 2 prime times 1, same thing. It's up to you. But I will be using this order. Okay, this is the product rule. What about the quotient rule? So when we have a ratio of two functions and we need to differentiate, yes, Justin?
Is it f prime over g minus f
No.
over g prime?
No, it would be the same thing at the top with minus, and the denominator would be g squared. So this is f prime g minus f g prime. The same thing with the product, but minus. And everything divided by g squared, not differentiated, just g squared. Again, you already know my habit, so it's 1 over 2. I keep them as 1, 2, 1, 2. Up to you. I accept any method. 1 prime times 2 minus 1 times 2 prime divided by 2 squared. Okay, we want to practice this. Yes?
So in the book, it uses like a triangle. Is that the same thing as the
when you're looking, oh, that's a differentiation, delta. That's a delta, the uppercase delta. Yes, you're looking at the proof, right? So you're looking on page 187.
I'm on 185.
Oh, you're on 185. Let's take a look. Yes, that's the delta x. The derivative of x
So
is a differential that the change in x or dx.
so nothing that we're looking at right now, because
They're showing a proof. This is a proof of the product rule. So you're talking about this, right?
Is it just replacing f of x and g of x?
Yes, they show u and v. They say the derivative of u times v is what? Is u times the derivative of v plus v times the derivative of u. So dv over dx, if you remember, that's one other notation. Do you remember the notations?
dy over dx.
So where's my checklist? 3. Here it is. If you remember, we discussed this. There are different notations. There are different notations for the derivative. Is this or this or this or this or this. So du over dx is the same with u prime. Is that what you were asking?
Well, I guess just the little triangle.
You mean this one?
Yeah,
This is delta x.
that's different from the delta.
It's similar to h, the
Okay.
tiny change in x. That is sometimes denoted by delta x, but it's little h. H approaches 0. Same thing. As the change in x approaches 0 or as h approaches 0. Same thing. We're going to get to in the next chapter, and we are going to talk a little bit more about this delta x and delta y and dx and dy. Okay? So here there's just a proof of the product rule or the idea, and then they came up with the rule right here. I'm just trying to simplify it, and I'm not, but if you want, I can show you all this notation. It's the same thing. So the derivative of f times g, they write f g prime plus g f prime. I just like to keep it fg. Okay, it's the same thing. Is that okay? Okay, very good. So let's choose some problems. If you have your books, please go ahead and choose anything you like from 3 to 26.
On what page?
189. So 3 to 26 on page 189. So we can practice the product rule and the quotient rule, and then we are going to look at slightly more sophisticated situations.
22.
22 it is. So let's start with...
That's not one pages, is it?
That's fine. 22 is fine. Let's take a look. We have g of t, which is t minus the square root of t divided by t to 1/3. This is a perfect pick. Let me explain why this is a perfect pick. Let's say I'm taking a test and you give me this function and say differentiate it. If you do not say how to differentiate it, I will never use the quotient rule. Why? Because I can simplify the function very easily, and because the denominator is only one term. If you don't specify, I will never use the quotient rule. Why? Because there is an easier method. So I'm going to say t divided by t to 1/3 minus t to 1/2 over t to 1/3. Because that simplifies things quite a lot. I was able to separate the fraction because the denominator is just one term. And then I copy the base and I subtract the exponents. 1 minus 1/3 is negative, it's, what is it? Positive 2/3. Minus 1/2 minus 1/3. 1/2 minus 1/3, the least common denominator is 6. And then I have 3 and 2, so it's 1/6. This is what I want to differentiate. Not spend my time with differentiating the quotient, because it's going to be much more difficult, way more difficult. So then g prime of t equals 2/3 t to 2/3 minus 1, negative 1/3. Then I bring 1/6 in front, and t, 1/6 minus 1, is negative 5/6. And I'm done. Yes, if I'm asked to simplify it, I'll go back and change it into, I will factor out t to negative, the larger of the two is negative 5/6, and so on and so forth. There is no need here to do that. The question is asking us to differentiate. It doesn't say how. So if I'm not told how, I will always choose the easiest route.
Wouldn't simplifying that further cause them to be fractions?
Yes, you will get a fraction if you do that. If you further simplify it.
But would we not require that?
It depends on what we do with the problem. So if you want to continue factoring in order to simplify it, let's go ahead and do it. So g prime of t, I will have to factor out the largest smallest of the two powers, of course. So the smallest of these two is negative 5/6. So I will factor out 1/3 and t to negative 5/6. Bless you. So then I have 2. From negative 1/3, I subtract 5/6. So the least common denominator is 6. And I need a 2 here. So 5 minus 2 will be 3. So this will be 1/2. So then I have the square root of t inside. And then minus 1/2.
But we wouldn't have to go that far, correct?
Not for this particular problem. No. But when we end up graphing these functions, yes. In chapter 4. Not in chapter 3. Okay, very good. So now let's choose, for example, 24, in which we have no choice. We're asked to find f prime. I have no choice but to use what? I have no choice but indeed to use the quotient rule. So I consider the top function 1, and I consider the bottom function 2. And I use the quotient rule. So f prime of x equals the top prime. Careful, because it's a product. This is not a trivial situation. So when I differentiate the numerator, 1 prime is 0, correct? The constant prime is 0. Then minus. Leave the minus outside. This is a product now. I have to use the product rule. The first function prime, which is 1, times the second function, plus the first function multiplied by the second function prime, which is when I differentiate e to the x, I get all this is only 1 prime multiplied by the second function, which is x plus e to the x minus. So let's go back to the quotient rule. I differentiated the first function, which is this. Then I multiplied it by the second function, which is this. Then minus. I copy the first function, which is 1 minus x e to the x. But now I have to multiply by the bottom function prime. So what is the bottom function prime? This is not a product, so this is much easier. So multiplied by x prime is 1 plus e to the x prime is, that's it, over the denominator squared. Okay, let's do this one more time before we simplify. So now this is 1 and this is 2 prime. So one more time. 1 over 2 prime is 1 prime times 2 minus 1 times 2 prime over 2 squared. So When I differentiated the top function, 1 prime is 0. I had to copy this minus. And now I have to apply the product rule on this. First function times the second function. The first function prime is 1 times e to the x. But I have to write plus. The first function gets copied, and I differentiate the second one, which turns out to be still e to the x. So I'm done differentiating the top. I copy the bottom. Then I have minus. I copy the top times. I differentiate the bottom. This is easier because it's a sum, no products. X prime is 1 plus e to the x prime is e to the x. This is not done by any means. I have to distribute, combine like terms, simplify the top as much as I can. So, because these two products have minus in front, I recommend let's take the minus outside, and now everything is positive. I don't want to have to distribute so many negatives. I may forget. So I distribute e to the x to these two terms, and I get x e to the x plus
X squared.
copy the base, add the exponents.
Oh, okay.
Then I multiply these two, and I say plus x squared e to the x. Then I multiply these two. X e to the x times e to the x is e to 2x. Remember, we changed this into plus. So plus 1 plus e to the x. This has to stay as negative. Minus x e to the x and minus x e to 2x. Should I show this step again?
Yep.
Very good. We took the minus from both of them and put them in front. Now everything is positive except what is inside. I can't change that. E to the x times x is x e to the x. E to the x times e to the x, I copy the base, add the exponents. X e to the x times x is x squared e to the x. And x e to the x times e to the x is x e to 2x. So far so good? This product is this. Then plus, because we took the minus in front. 1 distributed to 1, 1 distributed to e to the x, negative x e to the x distributed to 1, and negative x e to the x distributed to e to the x, negative x e to 2x. Are we okay? Questions? Okay, let's hope, bless you. Yes, Ali?
I'm sorry, I might have missed it. When you did the first step to differentiate,
Yes.
why is the derivative of 1 e to the x plus x e to the x?
You're talking about this here?
No,
This here?
yes.
Okay.
Yeah. Why that is a plus?
You mean here?
No, on the inside.
Here?
Yes.
Pull the
Because when I differentiated 1, I got 0. And then I put negative in front. And I said the first function prime is 1 times e to the x plus the first function times the second one prime. I didn't want to distribute negative 1. Anything else? Okay, let's see if anything goes away. I really hope so. So there is an x e to the x with a negative x e to the x. Good. There is an x e to 2x with an, and there is nothing else. I can't do anything else, so this is it. That's good enough. E to 2x, maybe I should just, it doesn't matter really. Plus x squared e to the x plus 1 plus e to the x. Everything over x plus e to the x squared. And this is it. And no, we are not required to do anything else. And that brings me to something that I forgot to tell you. This move on your test made me cry. Here it is. I circled it. I put a tear was there. If you look through the light with your test, you'll see my tears. So I don't want to see this. Is it clear why?
Yes.
So you cannot remove the argument of a function with something outside. So it's like saying sine 30 degrees over 30 degrees is sine. This is like removing the argument of sine with something outside of it. So this move made me cry. So make a note when you go back home and you redo and look at your
So
test.
is the problem done at 3 sine?
It's just 3.
So with a limit in front, as x approaches 2, this will approach 1 and the answer will be 3. But we cannot simplify portion of a function or an argument inside a function with something outside. Okay? I don't know why this came back to me right this moment. I apologize, but I wanted to mention that. So please. Okay. Any questions about the product rule and the quotient rule? Because I like to look at other problems. Any questions so far? Any questions? Okay, so let's take a look. We have several examples here in which I would like to practice. So problem 44, for example. Problem 44. We are given information and we are asked part A, part B plus C, part C, and part D. We can choose one. Important type of problem. In order to understand how to differentiate a product or a quotient. Also be able to determine the derivative of different functions by looking at graphs or using graphs to determine the answer. Okay, so that's another type of situation. And then 52, so I like to look at one of these, and that's pretty much it. So tell me what you would like to continue with. Okay, if you don't want to choose, I will choose 44D. And that is h of x equals g of x divided by 1 plus f of x.
What number is this?
44.
44D.
D as in dog, yes, on page 190. So we're given a bunch of information, and suppose that f of 2, so I'm going to write them on the side. F of 2, they say, is -3. G prime of 2 is 4.
Can we scroll down a little bit, please?
Yes. Sorry. So f of 2 is -3. Oh, I know why. Okay, f of 2 is -3. G prime of no, it's not G prime. I'm sorry, it's G of 2. Sorry. F prime of 2 is -2, and G prime of 2, they say it's 7. The question was asking us to find H prime of 2. Okay. Question. Can I determine the value of a function if I don't have the function? No. So in order to determine H prime of 2, what do I have to find first? H prime of x. And then plug in 2. I need the function first. Very good. So forget about these for a moment, and let's determine H prime of x. We are told that these are differentiable functions. All conditions are fulfilled. We can go ahead and find H prime of x. So what do I have to write? What type of function is H of x? A quotient of two functions. Perfect. So then I will get the quotient rule ready. The denominator will be 1 plus f of x, everything squared for sure. I would write g prime of x multiplied by 1 plus f of x minus
G of x
g of x. Of course, I ran out of room.
times
In parentheses, f prime of x. Why? Because 1 prime is 0. So one more time, this was function 1, and this is function 2. G prime plus function 2 times function 2 minus g times function 2 prime, which is only f prime of x. I have the function that represents h prime of x, so then I am ready to find h prime of 2. What will you tell me to write? Don't calculate anything, just tell me what to write.
G prime of 2,
Very good. Times
1 plus f of 2,
f of 2, awesome, minus,
G
very good, times
f prime of 2.
f prime of 2, and over 1 plus, very good, squared. That's it. All the information is given to us. All we have to do is just plug it in. G prime of 2 is 7. F of 2 is negative 3. But negative 3 plus 1 is negative 2. Minus. G of 2 is 4. F prime of 2, negative 2. So multiplied by negative 2 over 1 plus f of 2 is negative 3. So it's I have negative 2 in the denominator. Everything squared. I'm going to erase everything else. So
I
1.
remember that negative front one.
No, I'm just saying. I'm just going to erase everything.
Okay.
Because I wanted to write it, and then it was 1 minus 3, so it's negative 2 squared. So then the top is negative 14 and plus 8 divided by 4. So that is negative 6 over 4, or negative 3/2. So the rate of change of function h at 2 is negative 3/2. The slope of the tangent line to the graph of h at 2 is negative 3/2. Or the instantaneous velocity, if you want, at 2 for function h is negative 3/2. Any questions? Any questions?
So since
Yes?
we're doing the derivative of a function,
Yes? That was given like this. Was given as a function at the top and a function at the bottom.
okay, so then what's the difference of doing the derivative of a function right here and not having a limit versus the previous definition of a derivative of a function?
Very
with
good.
a limit?
Very good. For example, in this situation, if I am asked to use the definition of the derivative, I will have to write limit as h approaches 0 from h of x plus h minus h of x over h.
Okay, so it just has to state.
Instead, we're using the differentiation rules.
Okay.
Because it's asking for f prime.
Because it's asking for h prime.
H prime.
Yes, and we have differentiation rules.
Yeah.
Otherwise, it will take a big chunk of time.
So it's just a different way of figuring the.
It's the shortcut.
Okay.
It's the easy way.
Awesome sauce.
Yes, it's the shortcut and the easy way. But you're right. We still have to have in the back of our minds that the derivative is a limit as h approaches 0 from the difference quotient for any function.
But we
Yes.
don't have to write the
No, because we are using the differentiation rules now. But we should always remember that the derivative is a limit of the difference quotient when h approaches 0. Very good. Okay, so let's look at 52b. B as in boy. We're given y equals f of x divided by x squared. And we're asked, we're told that f is a differentiable function. Find an expression for the derivative of each of the following functions.